This is going to be another weekly review with kind of adding a little bit more stuff at the end to kind of show what's possible with like wall hanging. Kind of, it's the best way to describe it. So, with the review, first let's talk about inputs. With inputs now, um, we have the buttons down for mouse, um, buttons this down for frames so that you can't just hold the mouse button down. One example would be the cookie clicker kind of game we discussed in class where we don't want someone to just hold the mouse down. So what we could do is use this list to now only keep track of stuff, specifically press this frame, kind of stuff like that. And the way we do this is by having an update now for input, where now every single game loop instance or every loop of the game, what we do is now we just clear the this frame variables. So now, say you press the mouse down and you hold it, well, the button down will still contain that mouse button, but it won't be in the mouse down this frame on the next frame. So it's kind of a way to just expand input. We implemented something pseudo previously, but now it's kind of a more structured thing for both keys up this frame and keys down. Also, now we have text. Text is just something very similar to Polygon, where we just now have a fill style and then a text and then a font. The main thing that changed, though, is that now we use our context to translate scale and rotate. So inside of our game objects, for every draw, what we do is we save, takes a snapshot of what we currently have for like variables, locations, scales, and stuff like that. And what we do then is we then translate based on the position X and position Y. When we scale it up based on the scale X and scale Y, and then we rotate based on this rotation. And then what we do is then we do component.draw, which would just be then which draws it, which would be like the polygon or the text, and then we restore it back to what we saved prior. Um, The other thing we talked about was game communication. So one thing that we talked about, so like inside of the game object, we now have find, which then just finds a game object based off of some name. And then you can also do something with like find all with tag, where you could just have any variable like tag, for example, and you can filter it, use your game objects.filter to specifically find a tag. This matches more of the Unity style, where rather than doing find all with like a name, usually the only way you do it is with like a tag that you assign a specific game object or prefab or yeah. What else? Yep, similar with we have get component for game op or for component to component communication under the same game object. So you could just do this dot game object dot get component. But if you need to do a game object to game object communication, what you need to do is you need to use your this or capital game object, so the file game objects dot find, and then you would do your specific one, and then so for example, platform game object, and then you do dot get component, a specific component of that platform game object. And then we can kind of start with some changes that will be made. So with our player controller, one thing to note, you can ignore all the commented stuff. I was experimenting with some stuff, so with this platformer that we're trying to make. But one thing to note is that say we open live server and we just walk off the edge, you kind of cue this negative velocity or this velocity downwards on the screen, and we don't really want that. Obviously, we want a more natural jump and natural like fall. Um, so what you would do is you would do this. So first you would get the transform. What we are doing is when we are in collision, let's uncount this to explain this a little bit better. When we're in collision, what's happening is that our gravity keeps on being applied. And what we just want to do is we want to say, hey, reset our y velocity if we're collision with the ground. So we just do this dot transform dot or this dot rigid body dot velocity dot y equals 0. So now when we walk off, it's more of a natural walk off. Next, when we let me talk about one major change that we did have to make about my double jumping issue from prior to last week. Basically what happened was that inside of my player game object, my rigid body was instantiated before my player controller. So what happened is it resolved physics before updating physics. This kind of caused it to where during our update, my rigid body pushes your player into the platform, which will trigger a collision for my player controller. It's saying, hey, there's a collision with your platform and your person. So what's happening is you can jump 3 times and you are good to go. And then when you apply that jump, so then you're now down to 2 jumps. But what's going to happen is that my rigid body is being pushed into the ground first. So it'll be pushed into the ground. I'll say, hey, you have 3 jumps. And then when you apply that jump, you'll have 2 jumps, but it doesn't apply that velocity until the next frame because the player component was instantiated after my rigid body. So then in my next frame, my rigid body pushes it down more, and it's like, oh, you're in collision. Therefore, you are have 3 jumps again. It uses then the previous frame's jump to then jump, and then it continued to have then 3 more jumps afterwards. So kind of just a very unique issue that that I experienced. So if there's any issues on that, then you could always talk to me or Rick's about those type of stuff. There's a couple ways we'll resolve this in class eventually to have a more standardized way. But the main thing I wanted to talk about today was wall sliding. Not wall sliding, but like wall hanging. So in class, if you recall, we talked about the old Batman game and how we could actually hang on the wall if we wanted to. So hang on to the wall rather than falling on off it. So what I created was just a wall game object that's red with a collider and then a different vector 2 for scale, and then on side of my yeah, that should all be needed. So what we want to do is we first want to say, hey, if the other dot name equals the wall game object, that means we're in collision with the wall. Now with this, what we want to do is there's kind of 2 ways we can go about it. We can either collide it from the left side or the right side. The left side would mean other dot transform dot position dot y minus other dot transform dot scale dot y. This gets, oh, not y, sorry, x. What this does is it gets the leftmost point basically of our scale. And with this, what we can do now is we can say, hey, if the leftmost point is greater than my current transform dot position dot x minus this dot transform dot scale dot x, what we can do is we can apply that same logic of this dot velocity dot rigid body equals 0. what that means. So what should happen is if I comment these two lines out, is that when we go over, we're still sliding a little bit. And I think that has to do with gravity specifically. But that's kind of an issue that you could change by updating your gravity to 0, or there's yeah. So like for example, this is what we could do for gravity. For example, inside of update, you could have this dot rigid body dot gravity dot y equals 512, and then inside of here, you could set that equal to 0. And what will happen is every frame, it'll set equal to 512, otherwise it sets it equal to 0. And depending on how things are ordered, which it should work, still does that. And that's because let's try this way. So when we set rigid body dot gravity to, yep, now we can hang on to it. And now you have to apply it after you leave, but that's kind of a whole different issue that I was trying to explore, and there wasn't really a solid way of doing it. But what you could do is something like this. Now that we are in collision with this, what you could do is, if since you're in collision with the wall and you're on the side, what you could do is you could do a temporary variable like this, where you just say it's this dot equals false. And now, or sorry, true. And then what you could do is you could say, hey, if you are not in collision with the wall, then you can apply gravity. Oh, this. Now this won't work perfectly because there's no way to account for jumping while you're on the wall. So there's a couple ways we could do this. The first way to do this is I'd say the best way to do this next is inside of our if statement. I currently have it to where, and if you're not in collision with the wall, what we could do is we could remove that. And we could say, hey, if your arrow is up and your jump is left, what we can do now is we can create this jump x direction variable. Actually, no, let's do the other way. Let's wait on that actually. One issue we currently have is if we go onto here and we go onto the other side, we're not sliding on the wall. So it's a very simple fix where we just do another if statement inside of here where we do pretty much the exact same thing with a few differences. Specifically within this if statement, it would be plus instead of minus, and then it would be greater than. Because what you want is on the far left, you want the left side and then leftmost. So now if we go into here, we reload the game. And if we go to the other side, oh, do I still have gravity equals 0 on that? Let's remove that. Just temporary so that so now you have that. Now what you can do is you can now wall slide on the other side as well. With that though, now what we can do is that when we jump, what we can do is we can force now the player to if we can now force the player to jump in order to get off the wall. kind of. And this is what we can use jump X direction for. So we could do this dot jump X direction. And what we want to do is if you're jumping on the left side of the wall, we want a -1. And on the positive side of the wall, we want a +1. So that, and now what we can do is now we could say, hey, if your arrow up and this dot jump left is greater than 0, what you can do now is you can set your velocity equal to y. You automatically set jump X direction equal to 0. And then if you're in collision with the ground, for example, which in this case, that's kind of what it's saying, what you could say is this dot jump X direction equals 0. And now what happens if you're in collision with the ground and you jump, it'll just multiply this by 0. So it does the 0 velocity. If it's -1, it does negative velocity. And if it's +1, it does positive velocity. So now we kind of have this, and now we can increase that to 50, for example. And now when we go into here, we can move around. And now when we jump up, you see how we're kind of forced off the wall. Did I implement? Oh, nope, there's no jumps left. So yeah, then let's just do this to make sure that we have jumps left on the wall. So now when we go against the wall, now when we jump, we kind of jump off the wall. And that's why kind of that action that we don't kind of slide up against the wall and hit it. We can exacerbate this a lot by doing like 500. So you see jump normal. But when we go jump here, you see how we kind of launch upwards. So now we do that, and now we kind of have that kind of idea of climbing the wall. But if you don't like the sliding, what you then can do is kind of a workaround. What you could say is, hey, we don't want gravity while we're on the wall. But this is kind of a twofold issue. How do we know when we're off the wall? Well, with our current engine, we only have on collision enter, which is a little funky. Like it is not as good. It's a little janky right now. We don't have the full expansive collisions like Unity or Unreal has. So what you can do is a temporary workaround where you set your gravity of y equal to 0 when you're in collision with the wall. What you then can also do is now expand your collision, your statement to say, hey, if your input dot decrease down includes arrow left and your jump direction, jump X direction, does not equal, so since we're jumping to the left, we don't want the jump direction equal to -1. This prevents you from the jump direction equaling jumping towards the left on the wall. Then what we can do is then we can say, actually, no, that does not work. No, yeah. So what this will do is that while you're on the wall, you can't get off the wall unless you jump. Hopefully, in theory, I think that's how that should work. And then same thing for one with arrow right. And then what that means is that your arrow up is the only way to actually get off the wall, which means that then inside of here, you can do this. You could say, hey, this dot collision with wall equals false, or you could manually set it equal to this dot rigid body dot gravity dot gravity dot y equals 512. You could do either one of these, and that will fix the issue. This way is probably better because that. So let's see if that works. So if we go here, everything still works. When we're on the wall, though, we can't leave the wall unless we jump. We can't leave the wall unless we jump. We can't leave the wall unless we jump. Um, and then now if we jump though, what we want to now do is we want to make sure that we set the jump direction equal to 0 after we jump. So this dot jump x direction now equals 0. Because now what's going to happen, what was happening was that it was still negative order 1, which means that I couldn't control it. So now if we were here, we can't control it, but when we jump, I still cannot control it. Still can't control it. Okay, yep, now you can control it. Jump off the wall. And now what's happening though is that we're in collision with the wall, and once I get halfway through, it's like, hey, you can't do that anymore because it's detecting that collision. So then the final thing we have to do to kind of update this is have an if statement in here. And we need to make sure that we are inside the y values. So the idea is that we kind of use this idea above, but we reverse it and we say, hey, if the other position minus the scale, so the current position going upwards is less than our current position minus the scale. So then this should prevent us from having that issue on the top of the wall of not being able to move freely through it. So now we can freely move through it, but there's still kind of an issue with that. Until we jump. So obviously these are workarounds. One, let's see if I can bug it. Let's do this. That's console.log in here. And let's say below wall game object. Now we know we're below the wall game object if we're in there. We want to say on here, console.log the let's say left side to show that we're on the left side. On the other one, we can do right side. And now we also want to do console.log. We want to log our rigid body dot velocity y. So let's do this of gravity. We don't need velocity. Let's do side with wall or side collision with wall. And then let's do jump x direction. And then this should give us enough understanding, kind of see what's happening. So we're not in collision with the wall yet, so nothing happens. We jump over here, Now we're in collision with wall. Our gravity is 0. Side with wall collision equals true. Jump X direction equals true. Let's change these three to be inside of our update so that we consistently get those three. Okay, so yep. Now when we collide with wall, sidewall collision with wall is true. Our jump X direction is -1, and then we are now below the wall game object. If we go now on top, it says we're still below the wall game object. So that's one issue we have. Our jump X direction is 0, which is nice, but that's why it's preventing us from going across. Is that it's saying, hey, what we need to do is we need to see what is wrong with this statement right here. So if our other dot transform dot position dot y, and we go up the scale to get the top, if it is less than, is it just greater than? Is it just as simple as that? Because oh, because what it is we're saying, hey, our position dot y minus our scale, that's our top point. What we want is the bottom point. So we want to add that. So it's still saying side collision with wall is false. Now it's saying side collision wall. Okay, so then we can do this. We can say, hey, if we're not above it, which means that our position, our position minus the scale would be great. So if it's not other dot transform to y minus, so then if it is going to be less than this dot transform dot position dot y plus that maybe. Hmm. So we do our transform that position.y, and we subtract going up, and we say, hey, so this is our top of the. Okay, let's just constant like that. We can remove that. Comment out would probably be better. Okay, so that's 200. Which, does that make sense? Inside of our scene, we have a platform game object where it is at, or sorry, a wall game object at 800, 600 with a scale of 400. So yeah, that makes sense. Because you're going up 400 at Y position 600 to get a Y value of 200. So now inside of our player controller, we now want to console.log this dot, we can do remove this. And we want to see where the Y is. $320, which is not correct. What we want to do is we want to subtract this then. Let's do this now. There, dot engine, this, components, player controller, click and enter. We want that. So we can see the variables. This dot transform dot position dot y is 600, which the scale y is 400, so that gives us 200. The current position is 310, and we want to subtract 10. Why is my position feel so off? So, huh. Yeah, I'll get back next week. That should be good enough to kind of explore how to do some of this stuff. If you have any questions, comments, concerns, you can email me. My email's on the syllabus. Otherwise, Monday after class, I'm always available to talk to if you want something specific. I'm going to see what this is about and then kind of go from there on next week's video. Okay.